slope, derivative, and anything of that along those lines, right? Okay, so basically what we're looking at is integrals and rates of change. Okay, so if you write that out mathematically, we're going to be doing problems involving that, which we've already started, right? The fundamental theorem and calculus part 2 kind of introduced us to that. And the big thing with this section is the application aspects of it. Okay, so if I give you a velocity graph or a velocity function, can you find the distance a car has traveled, for example? Or can you find how far a particle has moved? Okay, all that is within this realm, and we really start to apply, you remember your relationships between position, velocity, acceleration. Okay, so that's what this section's all about, and it is probably the #1 pre-response calculus question. There's always at least one of these on the exam, sometimes 2. So we will put a lot of time into this effort. Right? If you get a problem that looks like this, mathematically, what would you answer? What would your next step be?
Would you derive it?
We have that antiderivative of the derivative, so what pops up? S of t.
Where is the x?
No, see there's no x here? Right? It's numbers. So again, next step, S of t from 0 to 4. Right? Yeah, that's all it is. Okay, so again, the pure math behind it, we've been working on, right? Keep in mind, again, this is only a fundamental theorem of calculus 2 problem if there's an x in there. So that makes it an area function, right? It's just numbers, so just do the calculations. All right. So this would be a rate or a derivative. We could also say it is a velocity. It can be any of those different situations. So we have any of the words for derivative? Yeah, rate. I'm sure something. Oh yeah, slope of the function. What you end up with out the back is the net change in rate, or etc. Right? This can also be called displacement, which we will talk more about Tuesday. So distance traveled, because this is now a position function, right? That's how much change in position there is. That's what I should have written here. That should be a position. Do something wrong with it. So. So big idea, right? Here's a problem. Here's an example of something you might see. Water leaks from a tank. No, I fixed it.
No, it's fixed.
so we have a rate, correct? And it's a function. What you'll know is that as water in a tank leaks out, the amount of pressure on a hole changes, so less water actually leaks out at a time as time changes. It's kind of interesting. It doesn't, water tanks don't leak at a constant rate the entire time they're leaking.
Would it slow down if you do that?
It slows because the water pressure decreases.
For sure.
Right, so we have, that's why we need calculus, because that rate is not constant, right? It's changing. T is the number of hours after. Oh, let's say 9 a.m. That's when the leak started, apparently, 9 in the morning. How much water was lost between 9? Sure. Some of you have your book open, and I'm unoriginal sometimes.
No, I didn't guess there is.
Okay, now you see the news, when they talk about oil spills or something, they say, we think this much has spilled. This might be one of the methods that they've used to calculate that. Okay? It does get, but they're always using a flow rate over time. Do you guys remember the Deepwater Horizon spill in the Gulf? Okay. All they could do was measure how much was coming out, approximate it even. That's why there are different numbers. Environmentalists make it really high, oil companies make it really low. Probably somewhere in the middle, right? They estimate the flow rate of oil coming out, and they use an integral to calculate over time how much has come out. Okay, so if we are given, and again, we're going to annotate these. We have a rate function, right? How do we get to a, see how this is worded, how much water was lost? Okay, that is basically a position change problem. So you have to read into that. You have a rate. They're asking you about a position change. That means we have to integrate. We have our function. And what are our integral limits? 0 to 2. Right. Okay. See, now the math part of this is not real difficult. 9 a.m. is 0, 11 a.m. is 2. 0 to 2 hours. Okay. So once you get the problem written, it's usually not that difficult, but you have to get there. Okay. And you do need to write this down. Don't just stab an answer on the paper. Right? So, what is the antiderivative of that function? Josiah.
I don't know.
Antiderivative 2.
That's 2t.
2t, okay. Good. Plus.
5t squared over 2.
Got it. You did know. There you go.
If it was 14, could you just simplify it to?
Yep.
Yeah. That would be the easiest way to do it. Now evaluate, correct?
Oh, by dividing by 2.
Okay. Nice thing about this, it has 0 and that makes that 0, so we're just dealing with evaluating it too. 14?
Yes, sir.
What are my units?
Meters per
Just liters.
Okay,
That's, you would have to divide it by 2.
liters.
It's just liters. You know how much water is left? Yeah.
Yeah, it's just how much water was lost, that has to be a straight up volume measurement, right? Liters or gallons or something. So 14 liters, and I'm gonna have you write these statements of water was lost between 9 and 11 a.m. You will have to make those statements. It will say, interpret the problem in context. And you have to actually write something of that nature. Because this is interpret
Is this just a guess or is this like
in
exact?
context.
The rate is always changing.
Okay. What do you mean?
So is like with this, that information given, is this going to exact now or just like that?
Okay, mathematically, with the information you're given, that's the exact answer. Now, in real life, it's kind of hard to measure, right?
Or bucket?
We don't, yeah, you put a bucket under it, but we don't know the function over the entire course of the rate of change, right? Like, over the entire course of the week. It's really hard for us to model that with a function. Because all we can take is instantaneous points and approximate it with a function. So it would be an approximate. Okay? But it's the same math. Keep in mind your units. And how they're structured. Because that can be a clue as to what function you're working with too. Okay? Your first derivative or position function is always going to be a singular unit measure like liters. Velocity or rate will be a liters per hour over time, and then an acceleration will have time squared. So, there you go. Okay, very basic rate problem. Got to interpret it and then the math. Kelvin.
Why, if we were like examining a particle moving across the axis, why would the area under the curve equal its total distance? If we were going to,
It would be displacement. We'll talk about that more tomorrow. Okay, or not.
Yay.
If you're gonna Tuesday, we will focus on particle motion problems because those are a very popular way to ask this question. If, in general, distance and displacement are two different things. Okay, so imagine driving from here to Glenwood to Rifle. Your distance traveled is Glenwood and then back to Rifle, right? You total those distances up, but your displacement is only here to Rifle.
Yeah.
Okay, so again, we'll talk about those a little bit Tuesday, but I think that is a basic address of your question. Okay, good. All right. You have your books with you.
In my locker.
Figure that.
okay.
Yeah, you know how much that is.
Well, we'll just give this a shot. Okay, we're not gonna get their number.
Because they feel like they control the economy too much.
The zombie population is increasing at a rate of 2 to the X. It would line up with our exponential stuff last
The
time.
answer is C, crossbow.
Silver tip. Okay,
No, it's zombies.
vampires.
Thinking
Number of cars passing per hour.
That's so boring.
That's what I did earlier. It's disintegrating. I think it just had
Okay. I got, and it says,
Poor child.
They got your test? What is this?
pass that hour.
Somebody would know
Test 56 cars.
They're doing like different cars,
So this is what happens.
train cars.
Maybe during the eco test.
you all are not that far off base. You think it's funny, but you're not.
Mr. Arthur used to count the dots in the ceilings.
What?
Did you used to count the dots in the ceiling tiles?
No. That'd be stupid.
Dad did.
I'll tell you this though, and why I say you're not very far off base. If you look at the Alaska Department of Fish and Game website, they have fish totals, fish counts, because the salmon spawn and then the babies live in the river for a year and then they go out to the ocean, right? But they have to come back up the river to spawn. They have sonar counting stations on these rivers,
One fish goes by.
like 100 of them on different rivers.
Oh, wow.
And they have somebody sit there
Oh, that poor
and count. Red salmon, pink salmon, king salmon, silver salmon.
That poor sucker.
They count them.
How much is he
I believe he
paid?
gets paid a
What's
lot.
the rock?
And they post it on the
How
internet
much did
for
that
us.
person
You
get
want to
paid?
count to a billion hours?
Just sit there.
So I watched the King River sonar
Well,
count
yeah,
station,
so
the red counts,
you
and it
want to
says
count having
20,000, and I'm like, I'm going to the Rush River. And
I feel like she would, she must be sitting there. doing,
How much
oh.
does that person get paid?
No idea. But they do have people making those counts. And it's crazy, but anyways. Okay, so here's some data.
Austin,
practicing for your team job.
I'll move up to Alaska.
I feel like that's like Dr. Seuss.
It's Dr. Seuss.
I'd rather back to Alaska.
This is an exponential one, right? How does it go down? How do you
Okay, so we are going
pass?
to approximate the total number of cars that pass the observation point with a midpoint sum.
No.
Actually, don't mind that.
Two sub-intervals.
Trapezoidal and midpoint, yeah, she understands, I'm like, okay.
Ready, set, go.
Ah,
You can do that math, I'm not doing it for you.
wow, thanks.
But again, a perfect example of a free response question. You guys asked for those, right? So we're hitting them.
Yeah, I think, yeah.
From, we will be specific
Yeah, like from work.
and make it from 7 to 9. If you're still struggling with these, I'd get assistance from Brandon Lewis since he knows how to do it,
As he's looking back in his stuff.
which is fine.
I don't remember the equation.
5 numbers. Well, split your two, get your two sub-intervals, what are they? split that into 2 sub-intervals.
Oh, I know. Yep.
Then one hour, spacing hours. One
What is this? It's a rectangle.
Because it's just going to 1,178 plus 1,100.
Hey, put the math on paper. You gotta do the work to get your credit. So I can think how to teach all the time until I actually do it. I'm gonna get paid.
Millions of light years off.
I like how that many cars passed in the first 30 minutes.
That's a rate.
The second 30 minutes,
It's an hourly rate.
This per hour?
So you do, that's an hour and one. And you multiply it by 51.
and then the next 30 minutes is another 1,400 cars.
That under per hour.
Like tractor.
That was natural.
At 7, the hourly rate is 1,047. At 7:30, the hourly rate is 1470. It's not saying that 1470 has to have that. It's saying, if this were 1 hour for the traffic.
Awesome.
1,470.
So this one you just do one time.
Right, so they take maybe a 1 minute sandwich at 7:30 and extrude that to a 60.
One time.
Right. It's like we're about there. So wait, you got Nancy? How many?
260.
That's about right.
33.
Okay, so write that in a statement that interprets this problem in context.
That's the observation point
Cars.
between 7.
Past the observation.
Between 7 and 9 a.m.
Okay. If you are stuck on the math, I will write it down. 2 sub-intervals. Okay, so 1 wide, 1 hour wide each, and then you have your midpoint height, so we're in the middle. Okay, and you can do that again with the left or right Riemann sum or a trapezoidal sum, all those are fair game. Okay?
Would it normally tell you which one?
Yes.
You have to tell you in order to expect a
Oh, yes.
solid answer from you, because we don't want to look at 4 different numbers. Question is, okay, that's your intro to integrals and rates. You sure about that?
Senior, is this on question?
Yep.
Okay, thank you.
Yeah, you think about? No, it should be.
Come on, I said. Oh, yeah, but that's not racist.
Stuck it together. Do Tuesday.
Again,
Is all that stuff?
Is day 2 Tuesday?
Oh, there is no meeting.
Oh, that's due
so
Wednesday.
here's the next couple days, hey, you have some basic rate problems due Tuesday, but do focus on that quiz. We have not made any memory cards yet for chapter 5.
Yeah, we have not.
Okay, so, that will probably just be an open quiz at that point. We'll make some, I promise. I just have, with all the people absent, I've just been like, it's not going to try on because it's going to be work. Tuesdays, Wednesday.
Tuesday's Wednesday. Quiz. Thanks.
So I think those are good.
What?
You want